All right, so for example number 2,
And you can look at my packet of notes.
I've got 9x to the 4th, right, plus 6x squared plus 1. Okay? Now, again, this is a simple example. We could do this using the power rule all day long. We could say that y prime, which is really dy dx, is equal to 36x, right? Because 4 times 9 is 36, right? And then minus the 1 from the 4, so that becomes 3x cubed, right? And then on the next one, 2 times 6 is 12, right? And then minus 1 from the 2, so I get x, right? What's the derivative of a constant?
0.
0, so that's it, I'm done.
I've got a question about the dy dx part.
It's the same as y prime.
Yeah, I don't understand like what is, so are we dividing there?
Okay, I'll give you a little more formal notation, okay? If I have this y is equal to 9x to the 4th plus 6x. In our textbook kind of talks about it, but they don't really do it in the examples. 6x squared plus 1. All right. So now to take the derivative of this with respect to x, the notation is take the derivative with respect to x. Now remember, whatever you do to one term in an equation, you got to do to all of them.
But you're not dividing.
Oh, so yeah, it's not dividing, it's just a way to say,
Well, it isn't, but you could treat it like that.
It's just a way of representing it.
It's just a
Okay.
way of representing it.
Okay, that's what was confusing the opposite.
Yeah, but when we canceled out the du's, you can certainly do that all day long. In fact, I'll show you how there's times when we take the dx and tack it on the back end of an equation. But yeah, but each one of these, I'm saying, let's take the derivative of y with respect to x. Then I'm saying, let's take the derivative of 9x to the 4th with respect to x. Let's take the derivative of 6x squared with respect to x. Let's take the derivative of 1 with respect to x.
what's with respect to x mean?
Well, because you could take the derivative with respect to anything. So at some point in time, you might have an equation that says y is equal to 3z plus 4k plus 3 omega. And so you have all these variables, and I could take derivatives of all the variables. This isn't until like calculus 3, multivariate calculus. But I still got to, if some of you guys are going on to be engineers, you'll have to do something like that.
Just be 3 plus
So I got to kind of give you the precursor now, right? Yes. Yes. Any other questions? Yes.
Where does the du come in that last equation?
Because it was a function. It was the function u equals some
Okay. Gotcha.
expression of x,
Okay.
right?
Okay, so that's just because the x is the variable in this. If it was like a t,
Right.
it'd be in
What's the
respect to
variable
t.
that I'm taking the derivative of?
So if there was like a t instead of an x, it'd be in respect to t.
Yeah, so it'd be dt.
Okay.
Does that make sense? That's great. That's a great observation. Yes.
It would just be 3 equals 4 plus 3. You took the prime of that. The thing on top that you wrote in red.
No, it's a little different than that. It's a little more complicated than that. Well, I don't want. I'd have to
Okay.
teach you calculus 3, but trust me,
How was what?
it would be different. So, anyways, all right. So, basically, and I'm going to erase this too, because I want you guys to kind of focus on what's on the board. Now, this is the derivative, but this whole thing is actually a perfect square. It's actually 3x plus 1. It's actually 3x squared plus 1 squared. Okay? Now, what we like to do in calculus is we like to take something. But by the way, this is really hard, right? To calculate. I could separate it and do the product rule, right? In other words, I could say 3x, the quantity 3x squared plus 1 times the quantity 3x plus 3x squared plus 1, and do the UV thing and plug it in the formula. But let me ask you a question. What if I said let u equal 3x squared plus 1? Okay?
Why would you?
Could I write y equals u squared.
Yeah.
Now you know why, you asked the question, why would you do that? Why? Because I could take the derivative of this all day long. This is easy, right? This is easy to take the derivative of this. All right, cool. Well, what would the derivative of this be? Yeah, so if I took the derivative of this, I would say the derivative of y with respect to u, because I have a function of u, is equal to u. Okay? Does that make sense?
So is that the answer? I get it.
Yeah, that's the answer, almost.
Okay, so you just to clarify, you came upon y equals u squared because u is going to be the 3x squared plus 1, so the parentheses, then the squared is just the squared outside of the parentheses.
Straight out.
Yeah.
Okay.
I'm just confused how you got, like, I understand how you got from 9x to the 4th plus 6x squared plus 1 to the 3x squared plus 1 squared. Like, how did you get there from 36x cubed plus?
Yeah.
Well,
Like, what are you?
okay, so the question is, Mr. Adams, you've got 2u. That doesn't look anything like that, right?
Yeah.
That's a great question. Well, we got a little more work to do,
Okay.
right?
So they won't give that to us. You're going to tell us how to get the 3x squared plus 1 squared.
Yeah, well, we're not done,
Okay.
right? So what we really want, though, is we want dy dx, right? So we really want, let me give myself a little room here. What I really want is dy dx. Now, how do we get dy dx?
That's what that is.
No.
That's dy du.
That's dy
The
du.
one that's
You gotta
to
do
do
d,
du,
you gotta do
and
du
then
times.
the one that's right in front of your head.
Over that's
Times.
Yeah, so I gotta say dy du, and then times du dx, right? So, well, here's my u, right? So I'm going to take derivative of u with respect to x. Does that make sense?
Yeah.
So 6x.
Okay, yeah, so then this becomes 6x. Does that make sense?
And
Yeah. So now here's what happens. Let's plug those in. I've got 2 times u. All right, that's my dy du times 6x. You guys with me so far?
Yeah.
But I want a derivative of y with respect to x. I've got a function with u, and I've got a function with x.
That's a problem.
That's a problem, right? But I can fix that because I remembered that u is really equal to 3x squared plus 1. All right? So this is 3x squared plus 1 times 6x.
Is
Wait,
it
wouldn't there be
2?
a 2?
Oh yeah, I forgot to write the 2 in. There's a 2u, right? So there's this times 2. All this stuff equals dy dx. So watch this. If I push the 2 through, I get 6x squared plus 2 times 6x. Then I get 36x cubed plus 12x.
So pretty got that.
Now listen to me, guys. After I've taught you all this calculus, if you see this problem, just use the power rule. Just keep in mind, I'm trying to show you that I could use the chain rule to get an answer. Okay? And sometimes using the chain rule is quicker. Yes?
Can you scroll back?
Mhm.
That first step is the chain rule.
Well, I haven't shown you the chain rule just yet.
Is that the thing you showed us yesterday? Wait,
Yeah, I'm getting to it.
Wait, but is,
We're building up to the chain rule.
is that kind of the chain rule?
It's kind of.
Okay.
Now watch, I'm going to do this whole thing in about 3 seconds.
Wait,
You
no,
could
I
have
still
done
have
it
a
with
question.
What's your question?
How did you get the 3x squared plus 1 squared? Like, where did that number come from?
What I did is I looked at this thing.
But so you just knew it? How are
Yeah,
you
no,
supposed to do
well, you practice. You gotta learn it. That's why we're here, right? So she's saying, the question is, hey, look, Mr. Adams, how did you look at that and just know to choose 3x squared plus 1? Well, I learned it. That's the simple answer. But what we're going to do in calculus a lot, we'll look at that thing and you'll go, that is difficult to take the derivative of. How can I change that and make it easy to take the derivative of?
That u.
And I said, u substitution is usually the way. And I said, well, and I chose, if I make this whole thing u, then I have y equals u squared. I could do that all day long. Okay? Now, you don't know that because I'm teaching it to you for the first time, but after we practice it and practice it and practice it, you're going to do this a lot. You're going to look at a very difficult equation, and you're going to go, there's no way I can derive it the way it is. How do I make it fit something that I know how to take the derivative of? And usually, we use u substitution. We either factor things out, and it factors out nicely to something we can take the derivative of, or we use substitution. Or sometimes we multiply it by something, but basically we manipulate the equation algebraically to fit something we want. We just got to make sure that at the end we plug everything in and make it better, okay? Yes?
So I mean, I understand the actual putting all the prime into the formula part, but the one part I was having trouble with on the homework was breaking up the equations into like, because there were some that were trinomials, and that was kind of difficult to break up to.
You would factor those.
Okay.
You would factor those, and what you would see is that sometimes you'd have u, and when you took the derivative of u, like for example, and when you took the derivative of u, you would end up with that second factor.
Oh,
Okay, I'll show you. We can answer those questions after we do the notes, and I might need to extend this another day. Okay, you guys ready?
Yeah.
Now the chain rule. I'll show you the chain rule real quick. I'm trying to teach it to you, and I want you to learn it. But let's take that same equation. If I say y is equal to 3x squared plus, God bless you,
Now he's got
3x squared plus 1 squared.
Is this 3? Example 3.
This is still example 2, right? Are you guys ready?
Yep.
Yeah.
Tell me if you see a pattern. If I say y prime, I'm going to take the stuff on the inside and ignore it. If I apply the power rule, I'm going to take this 2 and multiply it by the 1 that's not written down, but it's implied, right? What's 2 times 1?
2.
2. Times, leave the stuff on the inside alone. Now, this is the actual chain rule, what's the derivative of the stuff on the inside?
6x.
Hey, that's no accident. Think this is a game? You think I'm playing around with you kids?